Hope you're having a productive day. In this video, we will be working through question number 4 on the 2012 CAPE Physics Unit 1 paper 2. Let's get right into it. So this is section B of the paper, and this is question number 4, which has parts A, B, and C, and D as well. So part A asks us to state Newton's second law of motion. Part B reads, a rock of density 2,500 kilograms per meter cube with a volume of 0.002 meters cube falls from rest in a viscous medium. The rock is acted on by a net constant downward force of 30 newtons, a combination of the gravitational force and a buoyant force, Fb, and a viscous retarding force, Fd, proportional to its velocity, v. Fd is equal to 5 times the velocity. Part B asks us to draw a free body diagram showing the forces acting on the rock. Part B also asks us to explain what is meant by a viscous medium. Part C asks us to calculate the mass of the rock, the buoyant force Fb, the initial acceleration of the rock, and the terminal velocity of the rock. Part D asks us to sketch graphs to show how the velocity and the acceleration of the rock vary with time. After you've familiarized yourself with the question and what it's asking for, you can get into trying to solve. Part A, state Newton's second law of motion. I'm not going to write it out because I want to conserve space, so I will just vocalize it. Newton's second law of motion states that the force applied to a mass is directly proportional to the rate of change of momentum and is in the same direction as that change in momentum. More than likely, you will be able to write this in its equation form, which would be one of two equations that mean the same thing. The first equation is what a lot of people commonly use when describing Newton's second law, and that is force is equivalent to mass times acceleration. But this equation can be written in a different way when we consider what acceleration is. Acceleration is equivalent to the final velocity minus the initial velocity divided by time. When we multiply the numerators, we get mv minus mu divided by time. As you can see, mv is final momentum, mu is initial momentum. So what we have in the numerator is actually a change in momentum. And then the time would make this equation equivalent to the rate of change in momentum. And that is the second way of stating Newton's second law. So you can say force is equal to ma, or you can write force is equal to the rate of change in momentum. More than likely, you can get away with writing any of these two equations, either this one here or this one here. So that is the first problem. So part B asks us to do two things. First, draw a free body diagram showing the forces acting on the rock, and then explain what is meant by a viscous medium. So let's draw the free body diagram now. The free body diagram is basically a diagram that shows all the forces that are acting on an object. So let's say this is the rock and we want to show the forces acting on the rock. Now you would have to know what forces are acting on the rock based on the question. The question though gives us basically the information that we need. So the question says that there is a constant downward force of 30 newtons. And that constant downward force is a combination of the gravitational force and the buoyant force. So right there, the question tells you that there's a gravitational force acting, which acts downward. And there's a buoyant force that acts upward. The buoyant force is basically what we call upthrust. So I will just call it U. And the downward force we can just call mg, since that is weight. The question also states that there's a viscous retarding force proportional to its velocity. That viscous retarding force is going to be our viscous drag, which is a second force that acts upwards, Fv. So this is basically a free body diagram showing the three forces that are acting on the rock. And that would be second part there. So let's move on to explain what is meant by a viscous medium. This is something that I will also just vocalize instead of writing out. A viscous medium is a medium that will oppose the motion of an object that is placed within it. So if you put an object into a viscous medium, there will be a force that acts against the motion of that object. So that's viscous force. Now we move on to calculations. The question asks us to first calculate the mass of the rock then the buoyant force, which is the upthrust, the initial acceleration of the rock, and the terminal velocity of the rock. So let's go into calculating the mass of the rock first. Now from the question, we see that the rock has a density of 2,500 kilograms per meters cubed and has a volume of 0.002 meters cubed. With those two bits of information, we can derive the mass of the rock. Density is equivalent to mass divided by volume. So mass is equivalent to the product of density and volume. So the density was 2,500 kilograms per meters cubed, and the volume was 0.002 meters cubed. When we multiply these two numbers, we end up with the answer for the object's mass, which should give 5 kilograms. Remember to include your units, especially in the final answer. I didn't put them here because I'm saving space, but I ensure that I have the unit in the final answer. The second thing the question wants us to find is the buoyant force. The question stated that there was a 30 Newton force that was a combination of the weight and the buoyant force. So basically what we can get is that 30 newtons is equivalent to mg minus the upthrust, which is the buoyant force. It's minus because the upthrust is acting in the direction opposite of this force here. So we can write 30 newtons is equivalent to, now the mass we calculated was 5 kilograms, so it's going to be 5 times 9.8, which is the acceleration due to gravity, and then subtract u. So 30 newtons is equivalent to 49 minus u. Now we can add u to this side to get rid of the u here, and if we add u to this side, we have to add u to that side. So we're going to get 30 plus u is equivalent to 49. Now we're going to subtract 30 from this side, and we're going to subtract it from this side. So we get u is equal to 49 minus 30. And at the end of the day, we get u is equal to 19 newtons. So that solves the buoyant force Fb. Now we need to find the initial acceleration of the rock. To do that, we consider that the acceleration of the rock initially is more than likely going to be a result of just the downward force that is acting on the rock, because the viscous force, which is proportional to the velocity, is going to be very small. It is going to be very small if the velocity hasn't started as yet, which means that the force that we consider when doing the calculations is just that downward 30 Newton force. This force here. And remember that this force is a combination of the weight and the upthrust. So basically, what we have is that 30 newtons is equivalent to mass times acceleration. The mass is 5 kilograms, so we get 30 divided by 5 is equivalent to 6 meters per second squared. And that solves the initial acceleration of the rock. The last thing it wants us to calculate is the terminal velocity of the rock. At terminal velocity, the net force acting on the object is indeed 0. So we can write back the forces that were acting on the object, which were its weight, the upthrust, and the viscous force. And that would be equivalent to 0 at terminal velocity. Now we're going to put the viscous force by itself, which means we're gonna add the viscous force to this side, and we're gonna add it to this side. And remember that the combination of the weight and the upthrust was given as 30 newtons. So that is equivalent to the viscous force at terminal velocity. Now the question stated that the viscous force is proportional to the velocity, and the relationship of the viscous force is that it is indeed 5 times the velocity. So we can basically rewrite this viscous force as 5 times the velocity. And because this is terminal velocity, then we can assume that this velocity here is indeed the terminal velocity. So this velocity here is just going to be equivalent to, divide both sides by 5, 6 meters per second. Part D asks us to sketch graphs to show how the velocity and acceleration of the rock vary with time. So let's go ahead and do that. So when you're considering the velocity, it starts out at 0. So the velocity will increase, but not uniformly. And it will increase and increase until it reaches the highest velocity that it can get to. And that would look like this. So this velocity here is the terminal velocity. So this is velocity on the y-axis and time is on the x-axis. Now we move over to acceleration. The acceleration would be greatest at the beginning, and then it would decrease until it eventually reaches 0. So that would look like this. My curves are probably not the best crafted curves out there, but you get the idea. And with that, we have come to the end of the question. Right then, if you did all of this working out and the sketches of the graphs, hopefully your graphs are better sketched than mine, you would have acquired 15 marks and you would be one step closer to getting that grade that you want on the CAPE paper. Thank you all for watching, and I hope you've learned something.